Ma'am, in XOR, when you want to propagate D, ma'am,
Hmm.
what should be the other input? Like, you can take 0 or 1.
Yeah, anything, what you will get. If you take 0, what you will get. If you take 1, what you are getting. Tell me.
So, when you have both D's, ma'am,
Both the D,
yes, ma'am.
the XOR, it will be
Yes,
0.
ma'am.
It will be 0.
Okay, oh yeah, correct. Hmm.
CEHK. For CEHK, line justification is possible, not possible. Are you getting this? How many of you solved this problem? CEHK. The answer is line justification is not possible. No one have solved this? And for CFK, X01111 you will get. Suppose CEHK, students please, are you all listening? If you have not done, no issues. Sivanath Nikhil, have you completed the problem?
Yes, ma'am.
Okay, are you getting the first answer, line justification not possible for CEHK?
Combined, I got 011, ma'am. That first part I got wrong answer, ma'am. I have to recheck again.
Okay, second path.
Yes, ma'am.
Second path also this answer only you are getting X01111.
Yes, ma'am.
Ma'am,
Okay,
for
good.
CHK, I'm getting 0, 1, 1, ma'am.
Which one? First one now.
Yes, ma'am.
Let me do now. Anybody else?
Ma'am,
Kirti,
even I
Even I'm
got
getting
0 1.
011, ma'am, for first part.
first path you are getting 011.
Yes,
Okay,
ma'am.
let me check now. Mm, fault is stuck at 0 fault. So if I want to activate, I need to make C as 1. Okay, so here I will have D, and even here I will have D. Now I'm considering only CEHK. So my aim is to transfer this D through this path. So this D, which is present at C, have to now move to E. If this has to move to E, B should be NAND gate. B should be 1 or 0, NAND gate.
1, ma'am.
1. So if this B is 1, automatically this is 1. Okay, that let me check later, line justification. Okay, as of now 1, and I got this D here. So this D, I need to bring it to H. So small d, this should be 0. Okay, done. And this D, if I want to bring it here, my F should be 1. Yeah, propagation is done. Let me do the line justification. When I do the line justification, here I should get 1. So if I should get 1 means already one of the input is D. Can I get 1 here if one of the input in XOR gate is D? If I can get, when I can get, then what should be my B?
B is 1, ma'am.
No, we didn't go for this line justification as of now. Here, we have started the line justification with this XOR gate, first level. I need F as 1. One of the input is fixed. This is a fan out branch. I cannot do this D. I cannot change this D. This is fixed. What should be the other input? What the people who have solved, what did you consider here?
I took
When
it
I
as
will get 1? When I will get 1? D is 1/0. So 1/0 means when I will get 1 I should get. So it should be 0, 1/0. So D I can write here. Actually, this D is nothing but 1/0. Here, if I get 1/1, that is nothing but equal to 1. So when I will get 1 XORed with 0, I will get 1. 0 XORed with 1, Only in this condition, I will get my 1. Students, just think. One of the input is D, that is 1/0. Output is 1. 1, I can write it as 1/1. So the other input should be 0/1. What is 0/1? This is nothing but D dash. Can I get a D dash as an input across B? D dash is a fault. I cannot get it. So this is not possible. I cannot get D dash. If I get D dash only, I will get the answer as 1. Otherwise, I can't get. Okay, this is not possible as of now. Let me check here. For this E to be D, B should be 1. When B is 1, automatically this is 1. Automatically this is also 1. When this is 1, can I get 1? 1 XORed 1 is 0. 0 XORed 1 is 1. No, I'm not getting 0/D will be D dash. I'm not getting 1. I want only 1 here. And similarly here 0, this is 1 fixed. So if I make this A as 0, I will get. But where is the problem? You got this answer 0, 1, 1. But line justification with this XR, is it satisfied? Those are completed. Have you understood what is the mistake you have done?
Yes, ma'am.
This XR, here this D is fixed. I cannot change this D. And at the output, I need 1. Can I get 1? 1 XOR D. It cannot be 1. 1 XORed D cannot be 1. It will be D dash. 1 XORed D will be D dash. So here line justification failed. Clear?
Yes, ma'am.
So next C, F, K. Are you getting this answer? Whoever have done this? Sivanath, I've told he got the other one. Manisa, who have done this problem? One more I heard. Who's that? Anybody else have done this? I accept you people are busy with placements and today you had one more quiz. So I am considering it okay. But please solve it whenever you get time. Are you all listening to me? Please raise your hands, those who are listening to me. Those who are listening to me, please. Raise your hands. So only 36 students are listening to me out of 67. Okay. Gautam Reddy, what happened? Okay, you can put this down. Now, hope you guys have understood how to solve this heart sensitization method. If not, please solve this. Maybe you can take same circuit. You can take an example for yesterday we solved for E stuck at 0. No. So you same example you try for D, D stuck at 1. Please note down the small d. This D here stuck at 1. Other one, this fan out branch, B fan out branch here stuck at 0. You can assign some variable in this diagram. The variables for the fan out is not assigned. You can assign some variable and you can proceed. Again, I'll repeat the question. Same circuit, D stuck at 0 I told, right? Stuck at 0, fault at D, and stuck at 1, fault at first fan out branch of second primary input and stuck at one fault at first fan out branch of a second primary input. Is it clear, students? Can I solve for both the faults at a stretch? Can we solve for both the faults at a stretch and get the answer? Can I consider both the faults at the same time in the circuit and get a test vector? Or I have to do one after the other? Are you able to hear me?
Yes, ma'am.
Then answer. Can we, I have given you for the same circuit, I asked you to practice, whenever you get time, practice this. So for fault stuck at 0 at D, I have given, another fault also I have given. So can I consider both the faults at my circuit and get the test vector? Or I need to consider faults one after the other and get the test vector? No answer. Yesterday I was discussing about this. You cannot consider multiple faults at a stretch at a time and get a test vector. It is not possible. In all the ATPG algorithms, whatever, how many ever faults they are giving to you, you have to consider the faults one by one. So first you need to take the fault at D and check how many paths are there. Solve for all the paths. Then remove this stuck at 0 fault. Then introduce stuck at 1 fault and consider how many paths are there and solve it. Is it clear, students, at least now? Students, is it clear at least now?
Yes, ma'am.
So what is the answer? Can I consider many faults or only one fault at a time?
One fault at a time, ma'am.
One fault at a time. Be clear with this. Anusha, did you ask something?
No, ma'am.
Okay. So now shall we move on to the algorithm, which we were discussing yesterday? Shall I go ahead, students? Yes?
Yes, ma'am.
Yes, ma'am.
So in D algorithm, 3 steps: singular cover, propagation D cube, and primitive D cube of failures. In yesterday's class, we discussed how to get the singular cover and propagation D cube for 2 input AND gate, for 2 input NAND gate, OR gate, NOR gate. Any doubt in this? Any doubt in this? Do anybody have any doubt? Please ask me. No doubt? So now shall I explain how to solve the problem? Shall I explain how to solve a problem?
Yes, ma'am.
Now, assume that this is a circuit given to you. Question is, using D algorithm for the fault stuck at 0 at E. For the fault stuck at 0 at E. Find the test vector. Fault stuck at 0 at E. This is a circuit given to you. For the fault stuck at 0 in the circuit given in the figure, using D algorithm, find the test vector. So what you have to do is, you can see in the circuit there are variables for the inputs and outputs of the gate A, B, C, D, E, F. So create one table like this with all the variables in the circuit. With all the variables in the circuit. Variable must be assigned for the input of the gates and also for the output. Remember, variables should be assigned in the circuit for the inputs and output of a gate. So in the circuit, inputs and output variable is assigned. So with all these variables, I have entered I have entered all these variables in a table. I've created a table like this. Okay. Now, first gate, consider this as a first gate. AB input, D output. AB input, D output. This is a NAND gate. So in this table, A, B input, D output. So in those column alone, first you enter the singular cover of the NAND gate. You already know the singular cover of NAND gate, correct? Singular cover of NAND gate is, so maybe let me copy this and paste there. This is a singular cover of NAND gate. So 1, 1, 0, 0x1, x0, 1. This is A, B, Y, but here A, B, D. D is the output. So A, B, D. So there I am filling this. Next, go take the next NAND gate. This is also a NAND gate. B, C, E. So for B, for C and E, the same singular cover I am writing. If suppose this is not a NAND gate, this is some OR gate, then for B, C, E, I have to enter the singular cover of OR gate, that particular OR gate. Okay, so now these three gates are NAND gates, so I am entering the singular cover. Next, D, E, F. So D, so this line, then E and F. So in this column, here I am filling the singular cover of this NAND gate D, E, F. So first I need to always fill the singular cover for all the gates with respect to their input variable and output variable in those corresponding columns. Singular cover is now done. Similarly, how you have entered the singular cover, you need to enter the propagation D cube. Okay, you need to enter the propagation D cube. Now I will remove the singular cover and I will copy paste the propagation D cube. Yeah. There are two propagation D cubes. Any one you can enter, not an issue. Both are right. Any one you can consider. So in this case, I have considered the propagation D cube which is given in the first table. So D1 D dash, D1 D dash, 1D D dash, and DD D dash. Okay, I have entered the first propagation D cube across A, B, and D. Similarly, B, C, E, B, C, E, propagation D cube. And once again for D, E, F. This actually should continue. It's fine. Next is the propagation D cube for D, E, F. Is this clear up to this what we have done now? What have been done, is it clear?
Yes, ma'am.
Variable wise, each gate wise, first we need to fill the singular cover. Next, we need to fill the propagation D cube. Okay. So if you know the singular cover and propagation D cube, it's just entering here in this big table. That's it, based on the variables, inputs and outputs. The last step, primitive D cube for failure. The last step, primitive D cube for failure, which we call it as PDF. That let me explain you now. So when we want to do the primitive D cube of failure, we should now use the concept of activating the fault, propagating the fault, and line justification. The three things which we have discussed in path sensitization method, that concept, basic concept, we need to use it here. Okay. Now, where is the fault? Fault is at E. And what is that fault? It is stuck at 0 fault. How I will activate this fault? If E is 1, can I activate the fault? If E is 1, can I activate the fault? Or if E is 0, I can activate the fault at E?
E is 1.
E is 1 because the fault is 0. How I will activate? I will activate it with an opposite value. Please remember. This concept is required even for the next algorithm, PODAM. Activation means if the fault is 0, at that particular signal line, the value should be 1. So 1/0 is D or D bar?
D, ma'am.
D. So now at E, let me enter it as D. E. at E, this column, at this column, immediately after entering the singular propagation D cube, now I'm writing as D. That is, fault is at E, stuck at 0. I'm activated it by making this NAND gate input as 1. So 1 slash E, 1 slash 0 is D now. Now, activation is done. So D is present at E. This I need to take it to F. This I need to take it to F. So here I have D. This D, I need to take it to F. If I want to take this D to F, what should be my D value? To understand, to know the D value, you all know by default, the D value should be 1. But this algorithm, how it works is, to identify the value of D, it goes and checks the propagation D cube. So the corresponding this gates, this NAND gates, propagation D cube is here. This is the propagation D cube. Correct. So as per this propagation D cube, to take D to the output, what should be my D value, small d value? Here, first entry, if I check, it is D1 D bar. Actually, I have E and F in terms of D and D. Which among these 3 rows, which row is matching? Tell me, among these 3 rows, which row is approximately matching? First row is not matching because in first row, E is 1. E is 1, but in ours, E is D. So first row is not matching. Second row and third row is matching. And if I look at the third row, the D value should be, small d value should be D. But that is not possible. I cannot get a fault here. Fault is present only at E. So third row is also ruled out. So which is matching with our 2 entries is the second row. So based on that, my D value should be 1. So let me enter 1 D bar only possible. So let me here write D dash. D bar. 1 D bar is possible. For me, D taking it to D bar is also acceptable. D taking it as D at the output is also acceptable. My aim is to bring D or D bar to the output. Not an issue for me. Either D or D bar is enough for me. So I'm going with this. So this propagation is now done. Activation is done here. Propagation is done with the help of propagation D cube. Next, line justification. As of now, we have considered E as 1 to activate. To propagate, we have considered D as 1. Now we need to check, can I get D1? Can I get E1? If I get, what will be my ABC? So that step we need to check. To check that, we need to take the help from the singular cover. We need to take the help from the singular cover. From this, we need to take the help. So now first D. Can I get D as 1? Go and check D output. So this is the table which is related to that D as an output. Yeah, I can get D as 1 with the 2 combination. If I put either 0x or x0, I can get it. So let me enter here any one. 0x, I'm considering it now. I'm considering 0x, I will get 1. So 1 is possible. Next, can I get E as 1? That is here. Can I get E as 1? Now go and check. When I can get E as 1, this table we need to check. First one is ruled out because E is 0. Second and third possible. 0x, x0. Already I made B as x. So second one will be matching or third one will be matching. Already here I took B as x. Now I need to consider B and C as x0 or 0x. Which I need to consider?
X0.
As per this 0x, I need to consider here x and 0. So my final, now I'm able to do the line justification. So my final answer is 0x0. Or else here instead of 0x, I would have taken x 0. In that case, which one I will choose here among these two? Which one I should choose? 0x or x0?
0x.
0x. I need to choose 0x. So if I have taken in this way, my answer will be x0x. If I have taken in the other way, my answer will be 0x0. Any answer is right. So first we need to activate the fault. Next we need to propagate the fault. For the propagation, we need to take help from the propagation D cube entries. For line justification, we need to take the help from the singular cover. Suppose if I solve the same problem with the path sensitization, answers will be different or same compared to the
Same.
algorithm. Same. All these algorithm aim is same. Remember, they will not give different answers. Answers will be same. Directly itself, anybody, if you understood the concept, remember activation, propagation, line justification. Directly you can enter the values in this table and you can get the answer. Just if you are thorough enough, within few seconds you can get the answer. And as per the question, whether they have asked what is the procedure need to be followed, you can go with the procedure and verify your answer. Now let me take stuck at 1 at E. So what I have to do here, what entry I need to do here, if it is a stuck at 1 fault at E. Students, tell me what I need to write. D or D bar? I'm changing the question now. D bar. Okay, next step. I need to take the help from propagation D cube or singular cover. From the propagation D cube. So D dash, which entry is matching? 1, 2, 3. 3 rows are there. Which entry is matching? First or second or third? Second one is matching because you remember this D1 D dash, 1D D bar, DD D bar can also be written as D bar 1D because two propagation D cubes are possible. Now I want at E, D dash. Actually in my propagation D cube there is no D dash at E. But remember, propagation D cube can also be written in other way. So if I have written this propagation D cube another way, here it will be D dash and here it will be D. So I'm going concept. So D dash and here it is D and this one will be 1. Now can I get here 1? Yeah, I can get here 1 when I have 0 and X. Now can I get here 1 or 0? How did I activate the fault? By considering E as 0 or 1. Fault is stuck at 1. So I would have activated it with considering zero. So when for which combination of B and C I will get 0? What should be my B and C value?
1 and 1, ma'am.
1 and 1. Now what will be my answer? This is X. In this case it is X. X meaning is it can be 1 or 0. So can I consider that to be 1? Can I force the value 1? Because for the activation part, I need here 1. Compulsorily, I need 1. So I can consider this X also 1. Possible. This is X, don't care. It can be 1 or 0. So what will be the final answer? 0, 1, 1. The test vector is 0, 1, 1. Now everyone now solve for stuck at 1. At B, stuck at 1 at B, and second fan out. Second fan out. Stuck at 1 fault at B, B second fan out. That means here. Stuck at one fault at primary input B, second fan out. That means here, this point. See, this point is a fault. Solve it. And let me also solve here. Fault is 1. So at B, B dash. So this D dash, I need to take it to E. So I need to check this. I need to check this. Those who didn't understand, please listen, look, just monitor, observe what I'm doing. B is D. The other way is also right. So D dash here. This is 1. This combination. D at B, C is 1 and E D dash. D D dash are interchangeable. So D dash D. So I have brought my fault to E. From E, I need to take it F. If I want to take it to F, I can get only D dash. So this is possible with 1. Now can I get, since it is activators, B is fixed. First D1. Then I can get D1. Zero, 1. X01, are you getting? First I activated here. Then I propagated to E. From E, I propagated to F. Next, I did line justification for D. And I got A and B value. B is fixed because while activating itself, I fixed it as 0. So I cannot change this. So first I filled this. And I got A as X. C, while propagating, I fixed C as 1. It is a primary input, so I can have it. So the final answer is X01. Is it clear, students? Is it clear? Are you all listening? Any confusion? Step by step you need to do. Please answer.
Ma'am, that last X01, why are we writing?
Which one? This one.
The last one, ma'am, which is highlighted.
X01. I'm writing the test vector, final test vector, ABC.
Okay.
Is it clear? Satya Suresh, are you listening? G. Manaswini is on hold. Neelima. Satvik. Sai Sriram is on hold. Madhusri is on hold. Sai Kausik. Rohit. Sarfaras. Nikhileswar, are you all listening? Sindhu Teja, Sumant, Naveen. Preetam? Preetam,
Yes, ma'am.
is it clear, Preetam?
Yes, ma'am.
So first, for any circuit, look at the variables. Based on all the variable, create a table in a specific order as per the order, level by level. Make the entry. First level, all the gates and those variable, then move on to second level, third level, like in a sequence, proper sequence, enter the variables. Then look at the gates and accordingly enter the singular cover of all the gates. Next, enter the propagation d cube of all the gates. Third step, we need to consider the fault, activate the fault. And for each propagation, change the row. First gate propagation, one row, next row, like a row by row, you need to enter. Propagation, then activation. For propagation, you need to take the help of the, what is this? Propagation d cube entries. For the line justification, you need to take the help of a singular cover. So that is what D algorithm. So this is what known as D algorithm. In case if you people are not able to take the propagation d cube entries and take the singular cover entries, and if you are not able to do, listen here, if you are not able to do this last step, ma'am, activation, okay ma'am, I know what is propagation, ma'am, I know what is, I'm not able to this, I'm not able to do. In that case, listen here. Blankly also you can do. As per the algorithm, you know the singular cover or propagation d cube of all the 4 gates. You all know that you will enter. The last step, I'll tell you. Suppose you consider this B, which is stuck at 1. So go to B. Here you write, this is stuck at 1 fault. So activation will be opposite value 0. So 0/1 will be D dash. Just write here D dash. And this D dash, I need to take it to E. So here it will be D dash E. If I want to take it to E, what will be my C? This is an AND gate. What will be my C? Path sensitization method. What will be C?
1.
1. C is 1. Next, my D is now across E. D or D dash, NAND gate? D. Okay, from E, I want to take it to F. So this D will go, when it goes to F, it will be D dash because it is an AND gate. And what should be my D? NAND gate, D should be 1. 1. So now propagation is done. Line justification. If I want to get 1 at D, D is fixed already 0. If this is 0, with a 0 only, I will get D as 1. So A can be anything X. Done. Using the path sensitization method only, I completed. So now my final answer will be X, 0, 1. If you are not able to check with this and check with this, and if you are not able to do this, in one line also you can give the answer, it is acceptable. For the primitive d cube of failure, use the concept of path sensitization. I hope you guys are comfortable with the path sensitization, correct? Yes or no?
Yes, ma'am.
For the last step alone, use the concept of path sensitization, fill like this and give the test vector. But this singular cover entry, propagation d cube entries are required. Only then I will give full marks. For primitive d cube alone, instead of doing like this, so instead of doing something like this completely, you can give the answer in one step. That is also acceptable. Clear, students? Don't check directly, you can give the answer. So next I will move on to few definitions. We'll see. Fault cone. Fault cone is suppose if this is your circuit, maybe I'll take some bigger one. This is some bigger circuit. Here, fault cone means when you want to get the test vector, in some algorithm, in some methods, what we'll do is, the circuit is very big or huge. We divide the circuit into small parts and we will analyze part by part. So that way, when you divide the circuit into small groups, call it as a fault. When you, in ATPG algorithm, when we get the test vector, if the circuit is huge, for the complete circuit, we will not analyze at a stretch and get the test vector. The circuit will be divided and then partitioned, I can say it can be partitioned, and then we will get the test vector. So when you use this procedure, when you partition it, when you split it, or when you cut it, each partition we call it as a fault cone. Next is forward implication and backward implication. Forward implication means in any gate, if you know the input and if you want to get the output, we call it as forward implication. Backward implication means you know the output and one of the input. You need to identify the other input. That we call it as a backward implication. Backward implication is a unique determination of all the inputs of a gate for given output and possibly some of the inputs. That means you know the output, you know one of the input. You need to identify the other input. Then when you do this procedure, we call this, I am doing backward implication. Forward implication means you know the input, but you need to identify the output. Input and output is of a gate. Okay, input and output of a gate, logic gate. This forward implication. We look at this circuits now. First AND gate, if 0 and D is known to you, if 0 and D is known to you, are the inputs of these two, you know output is 0. Correct? So this is known as forward implication. In case if you know the output and one of the input, you can identify the other input. When you do this, we call it as a backward implication. Remember, backward implication means identifying the input. Forward implication means identifying the output. Okay. Next. J frontier and D frontier. This J frontier and D frontier we will be using in the PODEM, the next algorithm. J frontier and D frontier is almost actually similar to forward implication and backward implication. Forward implication means, what did I say? You will find the output. Backward implication means, I told you will find the input. So forward implication, I can say it is similar to, read this J frontier. J frontier comprises gates whose output value is known and you will be calculating the input. So this is related to backward or forward? J frontier.
Backward.
Backward. So remember J frontier and forward implication, backward implication, you just remember as a definition as a part of exam. But this J frontier and D frontier only we are going to use it in the PODEM algorithm. So now remember, J frontier means any gate is said to be a J frontier gate if the output is known and input you need to identify. Please remember, while solving the problem, I will ask you many number of times while solving. Sometimes even I will forget. J frontier means output is known, input is not known. D frontier means input is known, output is not known. Clear? So another thing, D frontier we will be using during propagating the fault or line justification. That way also you can relate. D frontier we will use during propagation or line justification. What we'll do in propagation, we travel from input to output. So you will know the input and you will calculate the output in the propagation. Am I right, students? When you do the propagation, you know the input and you will calculate the output. When you do line justification, you will travel from backward. You know the output, you will check whether this input is possible or not. So D frontier will go with propagation or justification. Propagation. D frontier will go with propagation. J frontier will go with justification. Please remember. In PODEM algorithm also, we will do line justification and all, propagation and all. So when I do the propagation, I should use D frontier. When I perform the justification, I need to use J frontier. And what are the demerits with the D algorithm? Single path sensitized at a time. As path sensitization method, if multiple paths are there, even in D algorithm, only one path is sensitized at a time. Many number of backtracing, because we need to check the propagation D cube, we need to check the singular cover, and it is a tedious job and it is a time consuming job. That's why from D algorithm, we move on to PODEM. PODEM full form is Path Oriented Decision Making Algorithm. PODEM full form is Path Oriented Decision Making Algorithm. So maybe tomorrow I will start explaining this PODEM. I'll take this circuit. This is a fault. And even here in the PODEM, we need to create a table like this. What all the variables in the circuit, we have to enter it in the table. All the A, B, C, D, from primary input, first level gate, second level, third level, fourth level. Like that, you need to enter all the variables and 2 more columns for D frontier and J frontier. So this table is important in PODEM. The answer has to be given in the form of a table only in PODEM. Okay, so tomorrow class I will explain you the PODEM. Before that, I forgot to explain you how to get the singular cover or the propagation DQ for XOR. I told you yesterday singular cover is not possible. Suppose if this is a truth table of an XOR, I can divide it into 2 groups, like having one as output, and the other group is this. Correct. Singular cover, what we did there. Suppose if this here, there are 3 combinations with 0 input. There is 1 combination with 1 input. So 1 combination I wrote as such. Among these 3 combinations, I was merging 1 and 2, 2 and 3, 1 and 3. Same way, if I do here, I need to compare second and third. When I compare second and third, 2 variables are changing. Do you remember, if 1 variable is changing only, I should consider this in a singular cover table. But here 2 variables are changing, so I cannot get an entry for a singular cover from these 2 combinations. Similarly, if I take this green color, 2 green colors, A is also changing, B is also changing. So I cannot make an entry in a singular cover. That's why I told singular cover is not possible for the XOR gate, but I can get the propagation D cube directly. How to get the propagation D cube directly is, now consider red to green. Consider red to green. First, that is second row, compare with first row. 0, 0 will be 0. 1, 0 will be D. 1, 0 will be D. Similarly, this you compare with this one, last one. So 0, 1 will be D dash. 1, 1 will be 1. 1, 0 will be D. So this comparison with both the green is done, completed. Now take the second red row, compare it with both the greens. So 1 and 0, 0, 0, it is 0. 1 and 0, it is D. Next, compare these two. 1, D dash, then 1 and 0, D. The same table I can write here now. This will remain same. This will remain same. Only difference is wherever D dash means D, this will be D dash, and here it is D dash, D dash, D dash, D dash. This will be D, this will be D dash. Similarly here, this green, compare it with first red. So 0, 0, 0, 1, 0, D, 0, 1, D dash. Next, this row you compare with the below red line. 0, 1, D dash, 1, and this is D dash. Next, this green color with the top red. 1, 0, D, 0, D dash. And these two. 1, D dash, D dash. 1, D dash, D dash. So from green to red. From green to red. Even here, here I did red to green. This red to green I did. Here, this green to red I am doing. Other way around, if you do, you will get this table. Is it clear, students? So this is the propagation DQ for XOR and XNOR gate. This you can enter. So propagation D cube and singular cover is fixed for XOR, XNOR, and NAND, OR, and NOR. If you remember this, as per the circuit, entry the singular cover, entry the propagation D cube, last step using the path sensitization method, directly fill the values. The algorithm is done. So tomorrow's class, I will explain you with the path FODEM method, and we will move on to the next fault table method. Thank you for today.
Thank you, ma'am.
Thank you.